Welcome back, chemists. Today we're going to talk about empirical versus molecular formulas. So we've talked about chemical formulas before, but we haven't talked about differentiating different types of formulas within our covalent or molecular compounds. So empirical formulas show the simplest whole number ratio of the atoms, while molecular formulas show the actual ratio of atoms in a compound. So it's important for us to remember that several compounds can have the same empirical formula. Now let me give you guys a real quick example of a molecular formula versus an empirical formula. So if the formula for something was P4O10, and that would be tetraphosphorus decoxide, the empirical formula would be P4O10, but for the empirical formula we would want to simplify as much as possible. So since both of those subscripts were divisible by 2, we could just simplify to P2O5, and that would be our empirical formula. All right, let's look at how many different compounds have the same empirical formula. So the empirical formula of CH, where we have 92.2% carbon and 7.8% hydrogen, is present in acetylene. Remember, that's how we exploded our pumpkins. It is present in benzene, which is some of the gas in your vehicle, and it's also present in ethylene. So these are 3 different compounds with different boiling points that have the exact same empirical formula. For the empirical formula CH2, so 1 carbon, 2 hydrogens, we have butene, cyclohexane, and formaldehyde, which are pretty different compounds, but same empirical formula. CH2O, this is a good one, where we have an empirical formula of for every 1 carbon, there are 2 hydrogens and 1 oxygen. This is what most of your carbohydrates have. Most of your sugars have this. So acetic acid and glyceraldehyde also have this same thing. Okay, so let's look at some examples. Determining the empirical formula if you're given the molecular. So all that you have to do is divide the subscripts by the greatest common factor. So for this C3H6O3, I could divide all of those by 3. The greatest common factor was 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. 3 divided by 3 is 1. So we have our answer for our empirical formula, which is our simplest, is CH2O. All right, now let's do C6H12. All right, so the greatest common factor, both of these are divisible by 6. So my greatest common factor would be 6, and simplified, this would be CH2. And we're done. That is our empirical formula. All right, for this last one, Ca3OH6, the greatest common factor would be 3, which would make this simplify to CaOH. All right, moving on. Let's check out some that we're just going to try together. Which of the following is the molecular formula if the empirical formula is CH2? So remember, simplest is CH2, which means it needs to be able to simplify down to this. So if we look at C3H8, that can't simplify at all. That is the empirical formula. So we're just going to say that is not it. Okay, C4H6. So if we simplified that, we would have C2H3, since those are both divisible by 2. That's also not CH2, so that is not the answer. All right, now C3H6, these are both divisible by 3, so CH2 would be our empirical, which is what we're looking for. So that is the correct answer. All right, so now let's go the other way, determining the molecular formula by weight. If we're given an empirical formula, an empirical mass, and a molecular mass, we can find the molecular formula by finding the greatest common factor of those two masses we're given. All right, so underline what we're given, circle what we're looking for. So if your empirical formula, that's something given, is C10H7O2, and its molar mass is 159.06 grams per mole, what would the molecular formula be if the molar mass is 318.31 grams per mole? All right, so it asks us what the molecular formula is. So how we can find this to find the greatest common factor is we can just divide those masses by each other. So if we do 318.31 divided by 159.06, we get something that is very, very close to 2. So we need to multiply all the subscripts in our empirical formula times 2. So we're going to get C, 10 times 2 is 20. H, 7 times 2 is 14. And O, 2 times 2 is 4. So this is our empirical formula. Not empirical, it's our molecular formula that we found using our empirical formula. All right, let's try one more together. So if our empirical formula is CH2O and its molar mass is 30.03 grams per mole, what would the molecular formula be if the molar mass is 180.18 grams per mole? All right, so we are looking for the molecular formula again. We need to first find a greatest common factor using those two masses. Now, if you have a hard time remembering molecular mass divided by empirical mass, just remember big number divided by little number. So big number is 180.18 divided by little number, which is 30.03. That comes out to be 6. So we need to multiply all of those subscripts by 6. So we've got C, 1 times 6 is 6. H, 2 times 6 is 12. And O, 1 times 6 to be 6. So we got C6H12O6 as our molecular formula. So this is glucose. All right, that's it for today. We will be practicing this quite a bit. Make sure you let your teachers know if you have any questions or problems. All right, guys, thanks for watching. Go out and be awesome.